Well, this is Jack Jackson back with our second of our series of videos on polynomials. And so let's recall how the long division algorithm works for, just that you learned in elementary school, for just for natural numbers. Okay. And notice here that what we're doing is we're dividing 3,568 by 21. So we're basically dividing this up into 21 groups. Well, the 3,000s will not, there's not enough of those to divide evenly. So you need to think of this as 3,500s. The 3,500s, we can put one of the hundreds in each of the groups, and then we're subtracting 21. I probably should put, you know what, I'm going to do it this way. These really should have zeros for placeholders. Okay. Then we subtract, of course the 68 is going to come down. 35 minus 21 is 14. So this is, we had 14 hundreds left over. That's not enough to break evenly in the 21 groups. So we take 100. So we make that 146 tens. Well, we can get 6 groups out of that. 6 tens in each group times 21 is 1,260. So we're multiplying here. So we say 35 divided by 21 is 1. 1 times 21 is 21. That's really 2,100. So we subtract. Then we take the 146 divided by 21. It'll do 6 times. We can estimate that by 14 divided by 2 is 6. 6 times 21 is 1,260. Subtract, we get 208. 208 units. That will, we can get 9 of those per group. 21 times 9 is 189. And then we have 19 left over. Okay. So, how do we check this? Well, we can check it, like as you see here. With 3,568 divided by 21 can be written in mixed number form as 169 plus 19 over 21. In the mixed numbers, we often suppress the plus there. We can check it by saying the 21 times the 169 and then add 19, and that should be our number that we started with. So we've got some names for some of these things. This part right here is called the dividend. This part right here is called the divisor. So we're dividing the dividend by the divisor. The whole number part that we get up here is called the quotient, the whole number quotient. And this part down here is called the remainder. So notice that we check it by multiplying the divisor by the quotient and adding the remainder to get the dividend. So this is the remainder. The divisor is here. The quotient is here, and this is the dividend. Okay, well, just as we saw with multiplication, our multiplication algorithms that we worked with whole numbers work exactly the same algorithm for polynomials. Well, same way, division is just multiplication backwards, so we're going to use the same algorithm here. First, we write our polynomial in decreasing order, and if we're missing some terms, it's best to leave a space there for some missing terms, or even write in 0. Like if this didn't have a 4x at all, you might write 0x, or just leave a blank there. Write this in decreasing order. Now we kind of check this by dividing the 2 into the 35 and see how many times that will go. We do a similar thing here. We're going to divide by the leading coefficient here. Now, we may have to use fractions up here for the coefficients, but we're going to make sure that this is going to cancel out completely. So what we're doing is we're taking the 6x cubed and dividing it by 2x. Of course, x cubed divided by x is x squared, and 6 divided by 2 is 3. So that goes right here in the quotient. And notice I lined it up over the x squares. So I'm going to line up like terms. Now I take the 3x squared times not just the 2x, which is going to be 6x cubed, but also times the 1 by all the terms. 3x squared times 1 is 3x squared. Now I'm going to subtract. Notice I subtracted over here. So subtracting is changing the signs, and it's easy to get confused here, so I'm going to write the change sign and then box it in or circle it or something so I can see what the original sign was positive, positive, but the change signs are negative, negative. And now when we add, or with the change sign, the first term cancels out. And you're going to do this, you're going to choose something up here for the quotient so that that first term will always cancel out. Now let's see what happens on the rest of the terms. And again, I probably should go ahead and still bring that 8 down. Okay, but we have negative x squared plus a negative 3x squared is negative 4x squared. So I divide the first term, negative 4x squared divided by 2x. Negative 4x squared divided by 2x, that's negative 2x. That goes right here in the quotient, lined up over my x's. Now I take the negative 2x times 2x is negative 4x squared. Negative 2x times 1 is negative 2x. I'm going to subtract by adding the opposites, so these negatives become positives, and use the change sign when I add. And when I add these together, this cancels out, and just as this part canceled out. So the whole idea is to cancel out that leading term. Now what's left is 4x plus a 2x is 6x, and of course I still have my 8. Notice each time I do it, this remainder at each stage is a polynomial. We could call it a depressed polynomial. It's a polynomial that's one lower in degree, and we keep getting smaller and smaller. And how do we know we're done? Well, over here we're done when the remainder is less than the divisor. Over here we're done when the remainder has a smaller degree than the divisor. So we're not quite done yet. 6x divided by 2x is 3. 3 times 2x is 6x. 3 times 1 is 3. Change the signs and add to get this to cancel out. 8 plus negative 3 is 5. Finally, this is the remainder here because it is the degree, which is degree 0, is less than this. Not talking about the number 5 being less than 2. That's not true. We're talking about the degree here. So the degree of this constant term is 0, and we are looking at a term that's less than this one up here, which is degree is 1. So again, this part up here is the divisor. This part up here is the quotient. This part right here is the dividend. How do you check it? Well, how do you express your answer? You can express your answer this way. Express the problem as 6x cubed minus x squared plus 4x plus 8 in parentheses divided by parentheses 2x plus 1, close parentheses. Or you can express that as a fraction, just like I could do over here. Divides can be written this way or this way. And we express our answer as a polynomial plus a fraction, which is a remainder over a divisor. So, of course, this part right here is definitely not a polynomial, just like this part over here is definitely not a whole number. Okay, but we do get a polynomial quotient. How do we check it? We take our divisor, the thing we're dividing by, times our quotient here, but then we have to add on our remainder, and it should equal what we started with here. The one step that I see most often missed when students are learning this is the adding up, as the subtracting part where they're changing the signs. So I try to really help you out with that by making sure we do this, of writing the change sign and circle it, and it's easier to keep track of if you do that. Alright, let's do another example. Here's an example. First of all, this is not in decreasing order, so I want to put it in decreasing order. 6x cubed minus x squared plus 8. And notice there's no x term, so I put a 0x in there as a placeholder. Or I could just left it blank, but I leave a space there at least. And this one is in decreasing order. So 6x cubed divided by x squared. Okay? X cubed divided by x squared is x, so I'm going to line that over the x's, which is why I need a spot there. And 6 divided by 2 is 3. So 3x times 2x squared is 6x cubed. 3x times negative 4 is negative 12x, again lined up under the x's. Change the signs and add, in other words subtract, and these cancel out. We got a negative x squared, a plus 12x, and a plus 8. Now negative x squared divided by 2x is negative 1/2. Notice you may have to use fractions there because this has to cancel out completely. Negative 1/2 times 2x squared is negative x squared. Negative 1/2 times negative 4 is positive 2. Change the signs from minus and plus to plus and minus. The x squared cancels. We get 12x plus 6. This is degree 1 remainder where we had divisor degree 2, so we're done. So the quotient is 3x minus 1/2, and then the remainder is 12x plus 6. If we write it sort of in mixed number kind of form, we get a quotient of 3x minus 1/2 plus the remainder of 12x plus 6 over the divisor there. So these are actually equal as functions. You could check this in your calculator by letting this be y1 and letting this side be y2, and they should check because they should be the same. Give you the same x's. The same x's will give you the same y's. Let's just do that real fast to show you how you could check. Of course, you can also check it by multiplying it out by hand. But here's a calculator check. Okay, so we can let y1 be one side there. Let's see, the original negative x squared plus 8 plus 6x cubed divided by parentheses 2x squared minus 4, and that should be the same thing as 3x minus 1/2 plus, now be careful here, parentheses around the numerator, 12x plus 6 parentheses divided by parentheses around the denominator, 2x squared minus 4. If everything's right, these tables should match up. And look at that, they do. So good deal there. Here's another example worked out. Okay, let's look at this example here. I'm dividing just by something simple here, x minus 3, or x plus 3. So I've got 6x cubed divided by x is just 6x cubed. But just 6x squared times x is 6x cubed. 6x squared times 3 is 18x squared, and then I change the signs and add. So I get negative 20. Now, negative 20x squared divided by x is just negative 20x. Notice the number stays the same, the power just goes down 1. So when I multiply, I get that, same thing. And negative 20x times 3 is negative 60x. Now I change the signs and add, this goes away. Then here I get 65x plus my 18. 65x divided by x is 65. 65 times x is 65x. 65 times 3 is 195. Change the signs and add, and I get negative 177. The thing I want to notice, this is a very simple thing. If it looks like x plus a or x minus a, something very, very simple, monic, coefficient 1, linear, power 1, monic linear divisor, look what happens. Look at all these 6's, the same number all over and over again. Look at these 20's, negative 20's, over and over and over again. Even the 65 again appears over and over and over again. Look at all these x squares. Look at all these x's. We've got a lot of repetition here. So there might be some way we can simplify this a bit and condense the notation. And in fact, that's what we're going to do. We're going to exactly do that to condense the notation. Okay? And let me show you how we're going to do this. We're going to do this with something called synthetic division. Okay? So the change the sign part you kind of do right at the beginning and make this negative 3. Then you just write these coefficients down in order. 6, negative 2, 5, and 18. Be sure you put a 0 in there if one's missing. Now, all you do here is first of all, you just bring the first coefficient straight down. That's going to be this 6 here. Then you do negative 3 times 6 is negative 18. So you bring that one straight down. Here you're going to add. So that's negative 20. And then you go like this to multiply. We did that here. Negative 3 times negative 20 is positive 60. Add is 65. Negative 3 times times 65 is 195 negative. And that's what I had here. And then I add and get negative 177. So notice this last one is your remainder. Right? See that right there? Where's the 65? The 65 was here and here and here. About the negative 20, that was here and here and here. The 6, that was all these places. The negative 18, that's right here. The positive 60, that's right there. The negative 195, right there. And so we're just condensed this down. Now, this is a nice little way of condensing this. It saves a lot of writing, and it's actually a little bit easier to do once you understand what's going on. But it only works when this is x plus a number or x minus a number that we're dividing by. And so here are the steps that it goes through. I'll let you read those. But here's the same example worked out. So when can we use synthetic division? Let's just circle the ones where we can. Well, we can't use this one because of that 2. We can't use it here because of the square. This one we can do it on. This one we can do it on. This one we don't need to do it on because we can just use the distributive property. This one we can use synthetic. We can use synthetic here, not on this one. Okay? So let's pick one and do synthetic for practice. Let's try this one. Okay? So we're dividing by x plus 8, so we write negative 8 out here. And we write the coefficients in descending order. 2, negative 8, 0, and 7. So these are constant x, x squared, x cubed. Right? Now, we just bring the first one down, 2. 2 times negative 8 is negative 16. Add negative 24 times negative 8, that's positive, let's see, 32, carry 3, 19. Add those, 192. 192 times negative 8, so this will be negative. Okay, 16, carry 1, 72, 73, 7, 15, negative 1536 plus 7 is negative 1529. Negative 1529. And so there is our remainder. So how do I write the answer down? Well, if I'm going to write it down using this, the last one's going to be a remainder. So this is plus a negative 1529 over our divisor, x plus 8. So we do sort of the mixed number kind of form. And then the next one is our constant. The next one from the right is our x, coefficient of x, and the next one's a coefficient of the x squared. And so that turns out to be that. Notice when you're dividing this, all the powers are going to go down by 1 when you're dividing this way. So it gives you a nice, little nice way of doing some division problems like this. Now this can actually be programmed into a calculator, and this calculator program here, you can read this, and this is another example worked out. And this tells you what to do. Over here are the statements you put in. Over here are comments of what to do. And this program is for a TI-83 or 82 or an 84. They all program the same way. You can tell how long ago I wrote this program because I didn't even mention 84. And here's how it works out. So if you want to do this and program it in, you can, but you don't necessarily need need to do that. Okay, and we'll come back to our third video talking about factoring a little bit later. So now we've talked about polynomial division and synthetic division in this video.